Hi, you're listening to Chip Chat. We're back with a three-part series talking about Intel Evo, which is a designation earned by some of the best laptops on the market today. You may have seen this badge on some laptops you're considering, or perhaps you already own one. We'll be diving deeper into the origins of Intel Evo and what it means for the future of portable PCs. Today, we're kicking it off with Josh Newman, Intel's VP and GM of Mobile Innovation, with an overview on the vision behind Intel Evo. Thanks for joining me today on Intel Chip Chat. For our listeners out there, would you mind giving us an intro about yourself, your name, your title, and what you do at Intel?
Yeah, thanks, Marcus. It's great to be here. My name is Josh Newman. I am the General Manager of Mobile Innovation in Intel's Client Computing Group. And among my jobs and responsibilities, I get to work with the large PC industry, the system manufacturers, and all the different component and software manufacturers to bring together the most exciting and best laptop experiences that we can possibly build together.
Wow. So, and how long have you been at Intel?
I'm at Intel a little over 28 years, but who's counting?
Wow, that's quite a long and successful career so far. What has kept you at Intel for so long?
Just a passion for enriching people's lives. I joined Intel when the PC was ramping in the 90s, right? The personal computer was a new thing, and we were trying to get one in every home and changing what people can do. And then I spent several years working on Wi-Fi technology to convert from the desktop PC to the laptop and make them something you could take around and take in the coffee shops, and really exciting time to help people have that PC with them wherever they want to be using it. And then, for the last 10 years, it's been all about some of the amazing things we can do with mobility, right? Making the form factor of the laptop even more mobile, last longer battery life, connect in new ways. And so it's been a really exciting progression to take that core PC experience from the desktop to just anywhere and everywhere people need to go to be able to use it and be productive and contribute.
Oh, you're not kidding. You said that, coming from wanting to put a PC in every home, and now we're looking at multiple PCs in a home, just lots of them everywhere. People have so many things. You said you're part of the Wi-Fi group. Now these days we're talking about upgrading your Wi-Fi because there are so many wireless devices connected to a single network, PCs being, one of those many devices.
Yeah, absolutely. It's been a really fun journey, and it's just amazing, not just what the technologies has been able to do to the PC, but what people have done with PCs, in the past 30 years, watching it go from, a device you would use to research or maybe create a Word document to the explosion of email, but now to just the creation, like with 3D printing and sharing digitally and all of the places you can post user-generated content. It's incredible what people do with PCs, and that continues to inspire me to want to do this for many, many more years.
Oh, well, that's good news, because I know we have, like a long journey ahead of us. But let's kind of shorten the timeline a little bit. And it's been just over a year since the launch of Intel Evo. I know that's kind of your area of one of your many areas of specialty. And Evo launched with Tiger Lake U, that's 11th gen, last September. So we're just over a year now. Has this first year of Evo lived up to your expectations?
It has. It really has. It's been, first of all, the exciting launch a year ago. We were really telling the market and really not just customers, but the PC manufacturers and the manufacturers who make display technology and all the different components of a laptop. We were trying to unite them toward a new vision for the future of the laptop, the new experiences that would enrich people's lives and delight them, and coalescing that industry together around this new vision for what we can do to create incredible laptops for the next 2, 3, 5, 10 years and beyond. It's been just exciting to see that energy and momentum come together with this incredibly vibrant PC industry. So it's really lived up in that perspective. And then just seeing it show up in the retail stores, in some of the advertising we've been doing, it's really exciting to talk about a new brand, a new experience, and let people know that they can and should expect more from their technology and what Intel Evo delivers.
And I heard you say, 5 years, 10 years. Clearly, this is something that's Evo is a part of the long game. But I did say
in the last year, but I know that work that has led Intel Evo up into its first year started years before that. Could you wind back the clock for some of the people who don't really know the whole history of, the making of Evo, about how this whole endeavor started?
Yeah, I sure can. It's hard to decide how far back to go, but I'll start really about 5 or 6 years ago. The state of the PC industry was a big but somewhat stagnant market. The sort of the state of the art of innovation in laptops was the brand new kind of 2-in-1 form factor. So it's the idea of taking what's great about a tablet and what's great about what we used to call the Ultrabook, a thin laptop, and putting them together so you can convert the screen over and hold it as a tablet or use it as a great PC, depending on what mode or what your usage needs were at that point in time of the day. And we were getting a lot of innovation together with the industry on how you can make those lighter, how you can make the batteries last longer. And we were starting to see innovation around adding LTE connectivity, trying different things with multiple screens in the device. And it was all exciting, but it was also a little bit all over the place. And what we were really looking at is how can we focus this energy for all the investments that Intel makes and all of the different innovation and investments that the industry is making. How do we bring all that together toward something that accelerates innovation that's going to matter to people, that's going to help them be their best selves and really impact their lives in new ways? And so what we did about 3 years ago was we started digging into what people really need. And that's some of the ethnographic research that our architecture team does. We have this incredible ethnographic engine at Intel to be able to learn what people need, learn what they want. So we dug into the lives of higher education students, some freelance independent professionals, basically the people who need the most from their technology. They have the most demands of technology. They need it to be super mobile and help them accomplish big goals in their work lives and their personal lives. And by understanding what they needed, we started to become clear about what we could really unify the whole industry around the next generation of great laptop experiences. And so we took all that energy that was already going into laptop innovation and we focused it on clear goals of creating laptop experiences that help people focus better, help them adapt to the various roles they play throughout the day, and be always ready for whatever might come up. And always ready is some of that mobile phone expectation that people have. It's got to start in an instant. It's got to, connectivity has to be something you don't have to think about, and you don't always have to be hunting for the charger. So those were things that were basic tenets of what the future of the best laptop experience was going to be. But then there was also this element of what do people actually do with their laptops? And how do we make sure we're tuning and perfecting that experience of how many applications do you have open? How quickly do you need to switch? How fast do the specific tasks that you're running need to run? What's the tolerance for startup time and applications and things like that? And so we took that deep ethnographic research, turned it into real experience verification metrics, which are kind of two forms. One is a specification that we give to the laptop manufacturers so they can make sure they're meeting all the right specifications. And then the other is a test suite, a real world test suite that really measures the performance, the behavior of the laptop under real world situations. So think of real world situations as you've got 50 browser tabs open in the background. You might have your virus scan going on, and then you need to quickly create a PDF of something to get to your boss right away. And that takes time. And with all that stuff going on, we wanted to make sure that experience was snappy. We also wanted to make sure under those real conditions of brighter screens and all that background activity that the battery lasted long. We wanted to make sure that if you needed to charge it could quick charge. Like those were the things people needed. And that would keep them in the flow, it would help them adapt easily and be always ready for them. And so through that understanding and this kind of definitions, we started to form this program that we call the Project Athena Innovation Program. And this has been about 2.5 years, so shortly following that research deep dive that we did. We created this industry innovation program that starts with the annual specification, then has the actual verification testing program, including those real world tests I was referring to that we call key experience indicators. And then there's the whole industry, kind of think of it as scaffolding that we put in place. So symposiums where we go talk to all the different component vendors of the laptop to help make sure they're developing the right specifications and the right products to build the laptops based on. We opened up our labs to be able to test displays and hard drives or solid state drives and memory, and making sure that all the different pieces of the laptop could meet that experience, and helping our fellow travelers in the ecosystem to deliver to that. And then we also put the kind of the big branding plans in place, because once we got to this level of sort of wonderful experience for all the work we were putting in as an industry, we wanted to make sure that we could, have a badge that would be earned by these devices that meet that experience, and that would help customers find it in an easy way. And that's what the Intel Evo brand and badge is all about. It's made possible by that Project Athena innovation program, which is all the work that goes in. And by looking for laptops that carry the Intel Evo badge or have earned the Intel Evo badge, a customer knows they're getting that great experience for the best laptops that help them focus, adapt, and be always ready for whatever might come up.
Great. That's definitely a very good flyover of everything about the program in a nutshell. You mentioned research, and I know that's been a key area that people are surprised to learn about Intel. They think that Intel is a semiconductor company, we just make chips, but honestly, there's a lot of very smart behind-the-scenes work that goes inside designing what the future of these features of these chips look like. How did the research insights and learnings from the research translate to the specification that you've outlined in the various generations? How do we get from those to the first generation of the spec?
Yeah. So there's sort of a couple phases to think about on how much time innovation can take. In this first year of Evo, once we really understood what people do, right, what these advanced users are doing and needing from their laptops, how many browser tabs are open, and what are the primary applications and types of tasks that they're doing on a regular basis, we were then able to take the technology that we had already designed into our processors, as well as some of the components around the processor, and we're able to tune them at a system level. Right, we have a lot of Intel technology that allows us to kind of dial in the performance. It's like fine-tuning an automobile, if you will, or super tuning it even. So in that case, we didn't necessarily have to change the engine, but we're able to program it and carefully tune to make sure it's matching that experience that people expect. And so every Intel Evo laptop that's launched in the last year has been tuned to meet these experiences. But it goes further than that, because now when we have that research, and we refresh the research every few months to see, are there different types of customers that we haven't reached yet, or are usage needs and trends changing such that what people are doing on their laptops and need to do on their laptops change. But by understanding what those things are they do and they need, we are actually architecting chips 2, 3, 5 years down the line already now on these new customer needs and expectations. And we can put sort of new tuning dials and knobs in as well, so that we know when we get to the actual system design, we have even more tools to be able to perfect the experience.
Wow, I think when people think of human-centric design, they think of, right-handed ergonomic mice, but they may not think about, custom designed silicon, or at least thoughtfully designed silicon that's actually for the applications of, human-centric use. One other thing that you talked about is the key experience indicator. So I think that plays a key part into the specification. So how do you decide on which are the right key experience indicators and how they mix together? Is there a compromise between the key experience indicators, or maybe you can shed some light on how those things are decided and how you formulate those?
Yeah, I'm actually glad you brought up the word compromise, because that was one of the key things we found from some of the early research was people don't want to compromise. When we looked at a lot of the laptops before Evo, we noticed something interesting, which was you get one experience that how the laptop responds to you, how quick tasks take to complete. It works one way when you're plugged into the wall and you're not worried about conserving battery life. But then it works a totally different way when you unplug, and you lose a lot of that snappiness in order to preserve the battery life. So one of the things we tried to do with the key experience indicators was remove that compromise and put that tuning capability, and the extra system design effort that we put in was all about being able to have both. be able to make sure that the system responded to you the way you needed it to, so you could focus, whether you were plugged in or on the go, and that the battery runtime lasted a long time. So you had the confidence to get through your meeting or your work or through the stint at the coffee shop where you don't want to have to go find the outlet in the corner. So removing compromise, having the and experience was a big part of this first year of Evo in the specification. And so the key experience indicators were built to really allow us to tune that in and then prove it out as we did the verification of the systems. All right, so for example, we have a responsiveness key experience indicator, which under real world conditions, so think, lots of apps open in the background, browser tabs open, which are constantly updating, connected to Wi-Fi, all the real chaos of the way people work, and unplugged. Then we test 25 tasks, right? Typical tasks, cloud-based and local applications. How fast does it take to create a PDF from a Word doc? How quick is it to switch from your mail to your calendar? How fast does it take to open a Zoom meeting? Right. So those are some of the typical tasks with all of that background going on. And we want to make sure that those things, meet, an excellent score in terms of how people perceive how snappy that is for the task in question. But then we take that exact same environment. And again, I mentioned earlier the screen brightness. With the screen brightness turned up to how people typically use the screen brightness, about 2/3 of the way up in the brightness indicator. And with all that background activity, that's how we measure the battery life under real cases of streaming and productivity and things like that, as opposed to the way things are traditionally tested or claimed, where you turn the screen brightness way down and you just run a local video playback and you shut everything off in the background and you disconnect from Wi-Fi. And so big difference in tuning for the real world of how people use their PCs versus what typically was done in order to measure and compare generation to generation in terms of how much battery life you should expect or performance you should expect. So that's really how the key experience indicators allowed us to really raise that experience expectation based on what people really do and how they like to work or play or whatever they're doing with their PC. But also strike that balance, make sure that we're delivering both. Right, the great responsiveness and that battery life, and that's what changed or was very different about the approach with Project Athena and Intel Evo.
You mentioned that a lot of these learnings came from looking at several years ago, looking at people in their work environments. These people that are called go-getters, right? They really want to get their work done in a bunch of various environments. But the last year and a half has definitely changed and narrowed the number of environments that people typically find themselves in. It's usually at home, like we are. How has that influenced what the spec is going to look like from here on? How has the pandemic shaped these set of requirements or aspirational goals?
Yeah, I think in a word, accelerated. So we started this looking at independent professionals and higher education students, and what they had in common was they worked in a variety of settings. Right, they needed to go from a coffee shop to a classroom or a client space to a co-working space to to their home apartment or home office. They were all over the place, but their expectations of their PC experience didn't change. They just needed to rely on it wherever they were. They needed the PC to give them confidence and project style in any of those situations they were in. But the other thing we saw that they did a lot more than any other PC users was that collaboration and video conferencing. If you think back to 2 years ago, video conferencing wasn't that common. Right? There was a specific set of people that use video conferencing a lot, but there was a lot of people that almost never did on the PC. And so as we started building the spec for this the current generation and looking to the next generation, we started speccing in better cameras, better audio systems, better microphones. And this was before the pandemic. As we all started to go remote after the pandemic kind of hit, we were working to accelerate that. Right? It became so much more important because what we observed was what was maybe a small subset of people who use those types of applications. Now it's everybody. And so everything we were planning into the future of the Project Athena specifications and the future of Intel Evo is so much more important to so many more people, right? Agile workers who will be hybrid for probably forever, right? The idea of some days you'll be in the office, some days you'll be at home, some days you go work wherever you want, wherever you feel comfortable and can be your most productive. And so the mission and the focus of what the initial research told us, and as we've done subsequent research since the pandemic started, we're seeing the resonance and the depth of that need just grow. And so it's really accelerated our focus and our passion to go accelerate this innovation in Intel Evo.
So with all this learnings and knowledge, at what point did Intel bring some of this vision and experience or even research findings to OEMs? Because ultimately, when they buy a Evo laptop, it's from one of our many OEM partners.
Yeah, so through the years of developing PC technology and processors for PCs, and as long as I've worked at Intel, most people don't realize Intel has such a close engineering partnership with our top customers, right? With the PC manufacturers that are developing the latest and greatest PCs. So there's a lot of Intel engineers that actually don't make chips. They actually make the technology. They're almost like they work side by side or shoulder to shoulder with the system manufacturers. And we've had that for years. And we've always sort of planned out maybe 2 years out in terms of what's the next great laptop you want to build, Dell or HP or Lenovo, Samsung, right? Like, what's your vision for how you want the chassis to look, and how thin does it have to be? What kind of display do you want to put in it? And what are the problems we can help you solve? Right? How can we help fit all that technology in that small package? How can we help you with the thermals? What are some of the other technologies we can help you enable in the industry? And so we've had that for years. And so what Athena and Evo did was it got us more focused, right? We said we have a clear vision for what we have to do next with the laptop, and next and next and next and so on. And then we really just channeled that incredible capability that we have, along with the relationships we have with the system manufacturers, to make sure that now, as we put our investments together, our innovation together, that we're doing it toward this kind of North Star vision of what the Project Athena experiences and the Intel Evo experiences need to be.
So what was I was going to ask, what is their initial response? But it sounds like they've been longtime partners and they knew that this was coming. Did they view these new Evo certified machines, or at least the proposal of it, did they see that as kind of extra homework? Was it a bit of a burdensome, or did they really view it as a net positive?
The short answer is net positive. It is asking more of them. And we said early on, we have this research that we believe really shows us the way for how to put our innovation together to create experiences that are going to matter to people and delight people. And so everybody kind of can get behind that notion. And we showed them the data and really believe it. And then we showed them what we were willing to do, right? So Intel is investing uniquely in terms of the component development, the system capabilities to create new kinds of ways of cooling all the technology inside these really small chassis, and doing it in a way that it can be super quiet still. And you can still create a thinner, lighter laptop. So that sort of desire for the OEMs, to the system manufacturers, to be able to work and get access to Intel's best technology and our partnership, as well as sort of this alignment or this agreement about these future delightful experiences that we should be working on together, ultimately, got them, pretty well invested with us to do this. It was a fairly obvious thing, as it developed, that it was a great thing for them to be doing, even though it is harder, right? The point of the specification is we are trying to raise the bar every year, and we're trying to make sure we're, not just throwing innovation here, there, and everywhere, but really focusing it. And so as we ask more of them, it's about just assuring that we're going in the same direction, we're pointing at the same North Star. And then at that point, it gets pretty easy from there. It's a lot of our customers, the system manufacturers, are just as passionate as we are about creating these experiences that really matter to people.
So with these guidelines, key experience indicators being so specific in some areas, did these guidelines hamper system designers, OEMs' ability to innovate and differentiate their products?
There's always trade-offs. There's always like that notion of, hey, we think a bigger battery is a great thing because it will make a much more delightful experience. But then you have to go look at the weight. And that's the engineering challenge. That's the beauty of the partnership. It's how can we do both? Like I said earlier, it's about and. How can we do what we wanted to do with a lighter system, but also meet these key experience indicators? And I can think of a few examples of Intel Evo systems that are lighter than laptops have ever been that still meet all the key experience indicators. And that's because we solve those problems together. And that might have come from enabling new battery technology, that then the system manufacturer could take advantage of. From some of that tuning I talked about earlier, in terms of how we carefully dialed in the amount of power that's being used to hit the right amount of responsiveness. In order to be able to achieve that kind of perfect balance of what people need. So that's the beauty of the co-engineering or engineering together. And it's really something only Intel brings to the system manufacturers, this level of co-engineering and expertise and just skills that the OEMs really, really appreciate.
So OEMs, I would imagine many of the ones that you mentioned, Dell, HP, they've been in the game for so long, as many of the other ones, Asus, Acer, Lenovo, they are all absolute black belt experts in designing systems. Yet you said Intel will devote some engineering expertise to these experts as well. So, I mean, just to take the devil's advocate or to understand like what an outside view may be, what does Intel, a semiconductor chip maker, know about making laptops and the components that go inside them?
Dell, HP, Lenovo, Asus, Acer, if I may be so bold, they got as good as they got because of the years of working with Intel. And it's because it's such a complex system. It requires a partnership with the way we make our processors and all of the different technologies and capabilities that can be tuned to the specific system. The domain experts that know that best live at Intel. But then we've been so hand in hand or partnering so closely with the OEMs for so many years that it comes off in their products and they make beautiful products out of it. But it's always been where Intel starts with the processor out and we start to build reference designs. And of late, in the last 5-10 years, we've had some of the most advanced concept and reference design system engineering teams that in the whole industry, right? In terms of some of the innovations around making the thinnest 2-in-1s, there are mechanical things that you have to do in the hinge that allows a 360 conversion that are really hard to design and get right. And a lot of that came from Intel. There are things you have to do in the thermal system where either it's super quiet fans or the placement of fans to get the cooling right, and the way we do different sort of thermal solutions for specific system designs. The thermal and mechanical engineers at Intel are doing that, and then we're working with the OEM so they can adopt that technology really easily, and working closely with their experts as well. So it's really, we have the expertise at Intel, I believe, to build the best systems possible, but we put that energy into making the OEM products the best they can possibly be. And that's always been the way we've worked in the PC business. It's about making the industry more vibrant and successful versus trying to do it all ourselves, because we believe that the customer experiences can be met and more customers can be delighted when you have the power of a whole industry working together versus what just one company could deliver.
Of course, and it's about the ecosystem, and I'm glad we're going there. That's what my next question is. Of course, there's work that goes with the companies and the designers that put these systems together, but computers really are, especially if you're from the desktop world, that these are really a bunch of components that fit together. In a laptop, everything's more integrated, but there's still a collection of components. So, how does Intel learn about the different types of components in the system to be able to understand what's achievable, right? It's very easy to set high watermarks, but Intel has to know that whether these things are realistic or not, and they can be aspirational, but they have to be realistic. How did Intel get that knowledge?
Yeah, so we have a really robust connection and set of relationships with the component suppliers or the independent hardware vendors that develop a whole range of technologies that are required to make a PC. Whether it's a solid state drive, display panel assemblies, battery technologies, memory, camera, especially of late, things like cameras and speakers and the audio components that go into these small laptops. So we have these really close relationships with all of those independent hardware vendors. And when we started Project Athena, one of the first things we did, going back again about 3 years, was we had our first Project Athena ecosystem symposium. And we did this in Asia. And we had over 100 companies show up across those domains I talked about. And they came to hear about our vision. What were the specs? What was the future of the experience we needed to deliver? And that's also when we announced our Open Labs. And so the Open Labs is a new tool at Intel. We have 3 different sites. We have China, Taiwan, and in the US, in California. We have 3 different labs where any of those component vendors can submit their components, and we'll test them to sub-specifications. The types of specifications that we know, as long as their components meet those, that when they go into the actual end system, that it can meet the Intel Evo full verification. And so we've been building that out more and more, and it's testing things like response time and power and thermals and fit into the types of form factors that they'll need to go into. And so in a lot of ways, it's extending the relationship of just sharing roadmaps and possible business opportunities, but actually extending it to co-engineering, helping them design the optimal components for the full laptops that we want to build with the OEMs. And again, it's something that we've been doing for the last few years. We've been growing that Open Labs footprint. It's really about raising the capability of the whole PC industry. And it's just something only Intel does. And I believe it's something only Intel can do in order to create that kind of focus and alignment within that broader PC ecosystem.
So through this collaboration, bring everyone to, I guess you said, sometimes even the real actual same physical space. Are there any technological innovations that have come from this kind of collaboration, or even this work to get Evo to where it is today?
Yeah, I would say that a lot of the good ideas are starting to flow now from these relationships and from these ecosystem symposiums. The second one, we started to have some of the IHVs bring some of their own demos and imagine some of their own possibilities. And instead of just showing up with whatever demo they were doing, they actually made it more relevant to the Project Athena experiences we were talking about. So a good example is there's certain component vendors that create components that allow the laptop to have better vision, to use the camera to basically see what the user's doing, what the head angle is, and help the laptop respond in more meaningful ways based on that context of understanding the kind of customer's posture and what they might do next. Or maybe it can see there's onlookers looking over the shoulder, so maybe it wants to dim the screen and for a privacy mode. And we started to see multiple suppliers show up with these great ideas and the component subsystems to meet them, and then want to work with us to make sure they got the power right and the performance right and the form factor fit right, so it could work inside of that larger Project Athena or Intel Evo system. And in a lot of cases, these were suppliers that were mostly focused at things like the Internet of Things type devices, or like they might have been doing like a smart mirrors for retail shopping experiences, right? But then they saw the Intel Evo and Project Athena vision and said, hey, I have some cool innovation. I think it makes sense for the laptop. Let me bring it to Intel and see if we can make it part of this bigger ecosystem. And that's what we hope. Right? That's the power of bringing the whole ecosystem together. Is I believe long term we're going to create experiences that delight customers better than any single company could do on their own if they were trying to deliver the whole stack top to bottom. And that, again, that power of the PC ecosystem is such a crucial part of what it is we're doing and what I love about the Project Athena and Intel Evo approach we're taking.
Great. I don't know if I'm making the right connection here, but Open Labs, when you say open, we think of open source. It's kind of, a sharing community. Do you feel that, or is the unintended but positive side effect is that we're bringing everything together, and that means that there's more sharing of technology? Does it knock down some proprietary exclusive technology kind of channels that used to happen where you could only get one kind of benefit through one type of system and you didn't have as much choice? Is that the side effect of what Intel is doing here? Does that mean that more technology gets out to more partners and more systems?
Yeah, it's definitely about removing friction and helping the hardware vendors make sure that they can create components that are aligned with the Intel Evo specifications. So really by open, it means, hey, everyone's welcome. If you're creating a component that's relevant to the laptop experiences we're talking about, and you'd like some help, contact us. We've got lab capacity. We've got test cases. You might have a new experience that we could think about writing the right test cases for and putting the right engineers on. So as opposed to something like a closed certification process where there's a big kind of subscription fee, you have to be a member of the consortia or whatever that might look like. Or think about certifying a device for a given mobile operator network, like a phone. It's not that. It's just much more open in terms of if you have a good idea or if you want some help developing your laptop component, we've got the labs to go help you do that.
Okay. And so you said, the first one you had 100 different parties there. Clearly, there's a lot of interest. But are there, aside from that interest, is there anything that Intel has done to, ensure or incentivize that even more people join? And how do we keep them along part of that journey and to, Evo for years to come?
Yeah, I'd say it's just creating excitement for what Intel Evo is. I think we're starting each ecosystem symposium, as we've tried to run them, even while we're virtual, we've tried to have them at least every 3 quarters or so. The intention is really twice a year, but with remote work, we've gone to a little bit slower cadence, but still very important one. And it's just each time we're getting more people showing up, more people who want to be part of the platform, because what they're getting more customer inquiries. They're getting more OEMs saying, okay, I have this new challenge for the spec 2 years from now. I need to see what technology you can provide me to help me hit that. And so it's a nice cycle or circle of, it starts with the vision. The OEMs work with us and create their plans. It works its way back to the supply chain, and then the supply chain comes back and says, how can I go faster? Or I have another idea to innovate. And so each time that as momentum of Intel Evo builds, the momentum of our supply ecosystem or our component ecosystem and those ecosystem symposiums is only getting stronger. So that's the really cool part. And so the way we make Intel Evo exciting is, well, the brand launch last year was a big deal. And come holiday of this year, as the systems hit the shelf, is going to be another really, really big focus on really helping connect customers to Intel Evo and all the promises of the best laptop experiences for getting things done that it implies. And so we expect that visibility just to keep reinforcing the excitement and the future innovation. And that's when things get really exciting, right? It's just going to keep spiraling as we continue to create great experiences and then imagine and dream up the next innovations that we can work on together.
So after the work with the component designers and the OEM and system designers, how does a finalized design become an Intel Evo machine?
Yeah, so it actually starts even before we decide to start the design work with the OEM. We sort of identify the plans. So it's not just any machine that gets built can come in and get stamped Evo. It actually is early in the planning process. We're deciding together on the specifications and which designs, which products within the OEM's product families we want to target together for Evo because they're aligned on the experiences. And so that process could take, as I mentioned, as much as 2 years. But it really gets to once we have the early engineering samples and, think maybe a half a year before you'd see the design on shelf. It's pre-production hardware, it's pre-production software, but that's where we start to really take it into the Intel Evo laboratories and test and start the tuning. And then begins about a half a year tuning process, or maybe it's a 4-month tuning process, where we're making sure that we are making that design as good as it can be against the Evo key experience indicators. So we have Intel test laboratories and engineers working round the clock in there, because we have them, on both sides of the, all sides of the world. And we're providing the OEMs regular feedback, and then their engineers are making changes to the final product. And so when they get ready to ship, by the time they get ready to ship into their sales channels, maybe a month or two before it shows up on the shelf at your favorite retailer, by then we know it's passed the tests, and at that point it gets to earn the Intel Evo badge because it's met all those experience requirements. So it is actually, there's certainly the early planning element and deciding that we're going to target the Evo experiences on a particular design. That's a really long lead decision, but it's that last 6 months when the hardware looks like it's just about the type of thing you'd expect to see from a production laptop. It's really working and iterating together closely to tune and perfect it over those last few months before it shows up. It shows up as something a customer can buy.
I think I gather I can kind of guess the answer to my next question, but I still want to clarify that with us bringing component companies and OEMs through our Intel Evo journey, this isn't a situation where it's like teaching a person how to fish and then that person can fish on their own from then on. This is are these OEMs able to just create another Evo laptop knowing everything they've learned from their previous one, or is there something that requires a constant co-engineering with Intel?
Yeah. So part of the philosophy is, if we have gotten to the point that the OEM can do the next couple generations of Evo without any help from Intel, then we're probably not pushing hard enough on the next generation experiences. So the idea is we may be improving the whole laptop ecosystem because we've taught the ecosystem how to do something to deliver one experience in 1 year. But the next year we want to do something so new that's going to take all of us together working hard. All right. And then each year we're going to keep raising the bar. The intention is that, over the years, we're really going to accelerate laptop innovation. But the whole philosophy is, let's take the really hard problems on that's going to take all of us to solve each year so that we can make that better. And so if we've truly gotten to a point where system manufacturers can do it all themselves, they don't need us, then we're probably not pushing hard enough on creating experiences that will delight our customers.
And I know from the first year of Evo, some of my favorite designs, there are many of them, but they're evolutions or updates to existing designs. Dell XPS 13 or the Lenovo Yoga. I have the Yoga 9i here. It's so sleek and black. This is the Evo model, but it is an update to the other Yoga. Are we going to see, or have you seen so far, the Evo influence of OEMs designing laptops specifically for Evo? Is that something that you're seeing a trend towards?
We have, some of the thing is a lot of the form factor innovation, the style of the designs, the materials that are being used. That's what the OEMs do incredibly well. And there's a lot of cases where maybe Intel's not going to add a whole lot of value there. But I'll give you some examples. Like, you talk about a refresh of a design that looks like last year's Yoga or last year's XPS, but maybe there is a problem specifically that we solve, like a new keyboard and touchpad implementation that just made things fit together better that they couldn't do before because they didn't have the right thermal solution, or they didn't have the board was too big that has to go under the keyboard. And through the Evo co-engineering, we solve that together. So they still keep their design language, their industrial design that it represents the OEM's identity, but now we're helping them solve problems that they couldn't solve before. Another great example, as the camera gets more complex, the routing, not just more complex, but higher fidelity cameras, all that signaling and routing gets a lot harder, and the camera's far away from the microprocessor, right? And so, how do we help solve those problems, right? To have a no compromise camera experience, but still put the camera where it should be, as opposed to have to make compromises like move the camera maybe to the bottom of the display or things like that don't quite fit the user experience people want. My other favorite example is, as people are innovating, as some of the OEMs are innovating with putting LTE and 5G in laptops, some of that antenna routing is some of the hardest technical work to go do with everything else going on in the system. And so helping solve these kind of, think of it, multivariable problems, and still not compromising on the performance, the style, the battery life, all that. Those are the things that we're really co-engineering together. And then the last thing I'd add is I would fully expect as we go through the next few years, we're going to see some pretty cool breakthroughs in the form factor and the design style, because we are opening up these new possibilities for the OEMs, form factor teams to really come up with new ideas.
Are those some of the technical innovations that are kind of born out of the Evo program?
Yeah, there's actually several. Some of them are coming yet, so I can't really disclose too much about those. But one example I would give is some of the context sensing, the idea of the laptop knows what's going on around it enough to be able to proact on behalf of the user. And my favorite example is if you're on the airplane and you're working on something that you want to keep private, and the laptop can actually detect that maybe somebody's peeking over your shoulder and shouldn't be. There's sensors, and then there's AI-based logic, right? Or it's really AI-powered algorithms running on the logic that is able to then create that use case for a customer to help protect the customer's data, help protect the customer's privacy in ways where they don't have to worry about quickly covering up the screen or having to look over the shoulder and telling the onlooker to buzz off. That's their personal decision, but we can help with some of that. And so those kinds of context-aware use cases were really born out of the Project Athena research and experience development. And we've got a lot more of that where that's coming from. There's some really good ideas that working with the industry and working with some of our own technology that's coming. We're going to be doing some pretty exciting stuff in those areas.
Very cool. Your mention of the privacy screen just reminded me that the most frequent times I see those, either they're the add-ons or the optional types of add-ons on the displays, are for commercial laptops. The ones that people use, or the ones that IT departments deploy on mass. I know that Evo launched first as with Tiger Lake on consumer laptops, but now there's Evo for commercial purposes. Can you tell me, is there any difference in how Intel defined what makes Evo for consumers versus commercial, or are they quite similar?
Yeah, they're similar. And when we first imagined Project Athena, we imagined it was really for both. We were looking at people who primarily bought through consumer channels, but the experiences we were onto, we knew were going to be a little more universal. And then, of course, with the pandemic and everybody needing remote and hybrid capabilities, and the laptop fundamentally becoming people's offices in the last 2 years, has really, as I said, accelerated that need, not just amongst consumers, but also in enterprise users or people who get their laptop from their IT department. So it's really that experience is the same, whether you buy the laptop yourself or that need for what you want out of a laptop when it's handed to you by your IT department. What's a little different with the commercial side is, in addition to those Evo experiences, there's also then the layer of the vPro protections that really delight the IT manager. So vPro is about the right security, the right manageability, right, the right productivity performance for the things that are going to delight the IT manager to know that they're giving their employees what they need, but they're also protecting their company's data. Where the Evo part of those commercial systems is about delighting the customer, the business end user, to make sure that they're able to focus, adapt, and be always ready for anything, just as the consumer or independent professional would want to be. So really, it's the same experience. The one thing we look at that as we look at IT and commercial environments is they have some more demands of the types of background applications that we have to plan for as we're defining these key experience indicators. And that's further informing how we have to architect our future chips and the future systems to not just work incredibly when it's a base kind of consumer version of the operating system, but also make sure that holds up when you switch over to an IT environment where you have more background applications and agents tracking your assets and deeper security protocols and everything else that different IT environments require. And just making sure that the Evo experience holds up in both of those scenarios. But the fundamental experience of helping people focus, helping them adapt, helping them be always ready applies whether it's a consumer laptop or a commercial oriented laptop.
So clearly, we've talked a lot about this Intel-led effort of Intel Evo, but as we know, we learn from the industry. The industry teaches us. We also help the industry as well. Have OEMs and the part of the ecosystem come back with feedback on the Evo specification? Has there been input or ideas for what's next, or how to improve, or how to change the specification?
Yes, we've got a lot of good ideas for how people would love to be able to go faster in certain areas. I would say as we plan out a new generation, we tend to be very aspirational, right? We tend to start out with a very early version of the specification that we start socializing with our OEM customers and some of the partners early. And often it's, hey, we want to go this far. If we're here now, we want to go here. And sometimes we work out and say, well, for the next year, maybe let's dial it in where we can really focus here. So there's a little bit of that, getting it dialed in, and we're trying to really constantly push how do we go further and further. But there's also been good ideas coming back in, like why aren't we going faster on making certain display requirements like OLED? Why aren't we making OLED everywhere? And what can we be doing to invest as an industry to go faster on something like OLED display technology, which provides richer contrast and brighter colors and tends to be something that really delight consumers who have those designs. Another example is why aren't we going faster on LTE and 5G in the system? And there are real challenges to be able to do that. But those are things that are inspiring us to say, why not? What is it going to take? How do we actually go and make that something we can deploy more broadly so more customers can get that delightful experience? So that's the kind of give and take that we have. And then we go back to the ecosystem symposiums. That's where we go and say, okay, maybe we're not ready as an industry this year, but how do we get there together for next year? What are those big goals we can take together and accelerate them?
Great. So one thing that I'm really excited about is, the future of processors coming from Intel. So at Architecture Day 2021, we revealed Alder Lake, which has a performance hybrid architecture, which is going to be both in desktops and mobile devices. So I think that this is a pretty big shift in x86. How will this affect the future of Evo?
Yeah, so we announced that at Intel Architecture Day, this new architecture, and a lot of it is it is really inspired by what we set out to do with Project Athena, the notion of having efficiency cores that can run really low power but respond to the demands of the current workload, and then turn on the performance cores when the workloads need even more. It's actually going to create greater capability for us to meet more demanding key experience indicators. Like if you think about all those background applications that are just normal in our day-to-day, that's what our research tells us. This is how people work. They've got tons of tabs open. They consume processor power, right? And then they want to do 2 or 3 things at once, and that consumes processor power. This new architecture is going to give us so many more degrees of freedom to make those experiences even better from a responsive standpoint and at lower power, right? Because we have these now choices of the smartness of the thread director, the Intel thread director, and the choices of the cores to be able to run them on. So it's going to unleash kind of new innovations. And then on top of that, we're keep working with the camera vendors and the sensors and AI partners to really come up with the next generation of really exciting, delightful usages. We've got a lot in store for the future generations of Evo, and we can't wait for you all to see it.
Oh, I can't wait either. Josh, thanks so much for your time, and thanks for joining me today.
Sure thing, Marcus. Thanks for having me.
That wraps up the first part of our deeper look into Intel Evo. Stay tuned for our next episode where we look at the social science and research in how real people use their PCs. You can find more episodes of Chip Chat wherever you get your podcasts. Thanks for tuning in, and I'll catch you next time.